We're going to have a look at two fairly difficult examples of similar triangles, and what we've got to do here is work out the length from D to C. Now, these are two similar triangles. The reason they're similar triangles is probably worth just mentioning quickly, is because that angle there must be the same as that angle there. They're Z angles, or alternate angles. This angle here is the same as this angle here because they're also alternate to each other, and in the middle these two angles are opposite. So I know the triangles must be similar because all of the angles are the same. So I know there's some scale factor which I'd multiply the little triangle by to get up to the big one. So that's what we need to go and work out first of all. So if I know that this angle corresponds to this one, I know this side corresponds to this one, this side corresponds to this one, and this side must correspond to that one. So the first calculation has got to be what have I multiplied by to get from 8 up to 20. So 20 divided by 8 gives me my scale factor. So that must be how many times bigger the large triangle is than the small one. So if I wanted to work out the distance from D to C, I know this side corresponds to this one here, and all I've got to do is multiply that by the scale factor. So 6 times by 2.5 gives me the length from D to C, which must be 15 centimeters. Likewise, if I already knew that this was 15, or let's just make a number up here, if I put the number 25 in here and I wanted to work out this one, I'd have to work backwards, so I'd be dividing by 2.5 to get back down to there. The other kind of similarity question, other than just basic triangles, tends to look like this, and again we'll just mention how we know that they're similar. Instead of alternate angles here, we've got pairs of corresponding angles. We know that these lines here are parallel to each other, so I know that this angle and this angle must be the same because they're corresponding, or F angles. And I know that this pair and this pair must be the same because they're corresponding again. And both of the triangles, the big one and this little one at the top, have that shared top angle there. So all we've got to do is we've got to work out the distance from C to D. Now, a huge piece of advice with this: I'd always draw two little sketches of triangles when I'm doing these questions, because in my opinion it makes it far easier. Lots of people tend to ignore me on this though. So 4.2, 6 and 4.8. That's the little triangle, and then I'll just draw a slightly bigger one down here, not to scale at all. So on this, what do I know? Well, the only thing I know is for certain is that there is a total of 9. So the obvious way of getting the scale factor is I know that this side here corresponds to this side here, so I can work out how many times the bigger triangle is than the little one by doing 9 divided by 6. That's 1.5, so that is my scale factor. So it must be times by 1.5. So we need to work out the length from C to D. Well, C to D is this length at the bottom here. So if I wanted to work out what that was, I've just got to follow my scale factor, and I'm doing 4.8 times by 1.5. Should be able to do that in your head. 4.8 times 1 would be 4.8, 4.8 times a half would be 2.4. Stick them together, that side there must be 7.2. We can just slightly extend this question a little bit. Let's say the question now asks me to find the distance from C to B as well. So again, I know that if I could find this whole length here, so that would be A to C, by multiplying 4.2 by my scale factor 1.5. So that would tell me that this whole distance here must be 6.3. So I know this total distance on this large triangle over here is 6.3. So if I wanted to work out the distance from B to C, that would just be 6.3 take away 4.2, which would give me 2.1.